Today we're going to do section 2.1, functions. Where are functions in the real world? Think of them as input-output situations. For example, a thermometer. You can compare Fahrenheit to Celsius. You can have one as an input, one as an output. Soda machines. A user puts in money, pushes a button, and a specific item drops into the output slot. Next, you'd have shadows. The length of a shadow is a function of its height and the time of day. Some words to take care of. First of all, relation is a mapping or pairing of input values with output values. Domain is the set of all input values. And when you're looking at a graph, it would be the set of all x's. Range is the set of all output values or the set of all the y's. And a function is a relation for which each input has exactly one output. So all the x's have to be different. Identify the domain and range of each relation. The first one you see there is a pair of input and output. The first box is the input values. The second box is the output values. So first of all, to talk about the domain, and notice the squiggly brackets, that says that it's going to be a set, and the set is -3, 2, and 3. And then the outputs is the range. So in that set, we would have -2, 1, 3. And again, notice the squiggly brackets, that says that it's a set. In the next box, you see a relation where you've got x and y. The domain for this is going to be the set of all x's, going back to our definitions. So the set would be 0, 2, 4, 7. And then the range is going to be the set of all y's, which in this case would be 1, 4, 9. Notice I put those in ascending order from least to greatest, and I did not need to put 1 twice. Once you say 1, you only need to say it that one time. Looking at that relation of x and y pairings, first we have ordered pairs. The first ordered pair in that relation would be the point 0, 1. Ordered pairs you can think of as points. The second point would be 2, 9, and then you'd have 4, 1, and 7, 4. Those are the 4 ordered pairs. X coordinates, what are the x coordinates? The first one is 0, and then we have 2, 4, and 7. Y coordinates, we have 1, and then we have 9 and 4. Notice I didn't need to say 1 again because it's already a y coordinate. Next, just to talk about quadrants a little bit, just to refresh your memory. Quadrant 1 is where the x's are positive and the y's are positive. Quadrant 2, x's are negative, y's are positive. Quadrant 3, the x's are negative and the y's are negative. And then the last is quadrant 4, where the x's are positive and the y's are negative. And then you've got your x-axis that goes horizontally, and you have your y-axis that goes vertically. Next up, is this relation a function? And explain. Yes, this one is a function because each of those inputs has exactly one output. -3 is only going to 2. -1 is only going to 3. 2 is only going to -4. And 4 is only going to -4. So even though 2 and 4 are going to -4, each of those inputs has exactly one output. Is this one a function? In this situation, it would be no, because the 1 is going to 2 different outputs. Okay, so it depends on what the input is doing. If the input is going to more than one output, it is not a function. Vertical line test. We can use the vertical line test to test whether something is a function or not. If you look at that first one, if you're just looking at the parabola, the U-shape blue on that first graph, notice that anywhere you draw a vertical line, like if you, for example, you place that red line in there, it's only crossing it once. So that makes it a function, as long as any vertical line only crosses one time. The second graph is not a function because if you notice that red line, it crosses the blue parabola, the curved shape, it crosses it twice. That's what makes it not a function. This next part is not in your notes if you're using a note packet. But if you look at that first graph, that's a W, I can draw a vertical line anywhere I want. Notice I've drawn 4 different vertical lines, and it only crosses that W at one place. So that means, yes, it is a function. What about the C? The boxed C, that would be. If I draw a line right there, that vertical line crosses twice. So right away, I know, no, this is not a function. Look at the next one. That's just some dots, and they are open dots, but those are some dots. We've got, if I draw a vertical line there, it only crosses once. If I draw another vertical line, again, it only crosses once. But if I draw this last line, notice it's crossing those dots. There's 3 of them. So it's crossing 3 times on that vertical line. So again, this is not a function. Now we're going to learn to graph using a T-bar. What you need to do first is pick 3 x's. It does not matter which 3 x's you choose. I'm going to use -2, 0, and 2. You can use those same 3 every time if you want to, or you could use a totally different 3. I always suggest using 3 x's, however, because then your line is going to be a straighter line. So I'm going to use -2, 0, and 2. To start out with, if I plug in -2 into that equation, y equals -x minus 1, it's going to be y equals -2 minus 1. Next, that 2 becomes positive because a minus negative is positive, so 2 minus 1 then is 1. So if I take that 1, then I can move it up here, so I've got the point -2, 1. Next, if I plug in the 0, I would get -1, and if I plug in the 2, I would get -3. So now if I want to graph those points, think about if you're starting at 0, 0, the first point is -2, 1. So from 0, 0, you'd move to the left 2, up 1, and that would give me the point -2, 1. Next, we'd graph 0, -1. That's just 1 down on the y-axis. And then 2, -3. From 0, you would move over to the right 2 and down 3. It's always x-axis first, then the y-axis. And then we would draw the line. Make sure you have arrows on both ends because this line goes on forever. Next, we decide whether the function is linear, and then we're going to evaluate f of 3. If you look at that function, f of x equals x squared plus 4x minus 1, that is not linear. And the reason it is not linear is because it has an x squared term. When you have x squared in your function, it's actually going to be a curved graph. So that is definitely not linear. So now if I want to find f of 3, first we plug 3's in for the x's. So it would be f of 3 equals 3 squared plus 4 times 3 minus the 1. And then for the next step, make sure you follow the order of operations first. So I'd have to take 3 squared is 9, plus 4 times 3 is 12. Bring down the minus 1. 9 plus 12 is 21. Bring down the minus 1. And that leaves us with 20. So that would be f of 3. f of 3 is 20. Next one. Is g of x equals x minus 11 linear? That would definitely be yes, the function is linear because it has the form g of x equals mx plus b. If you remember, back in Algebra 1, y equals mx plus b is always a line. So now if I want to evaluate g of 4, if I plug the 4 in, it would be g of 4 equals 4 minus 11. I just plug the 4 in for both of those x's. And then we only need to do what's on the right side of the equal sign. So next I would take the 4 minus 11 and get -7. And that concludes section 2.1.